I've worked with all of the products, so I know all of them. I've worked with bone marrow, I have bone marrow publications, I worked with fat, umbilical cord, of course, blood, and the cells. You don't want to say that. You want to talk about instances of, there's a lot of data out there that suggests that using this type of product when you have an autoimmune disease or you have specific issues may be better than using your own bone marrow, your own product. Besides that, you also want to discuss, you need to understand that when you take bone marrow, you take fat, either one of them, it requires a surgical procedure. That surgical procedure, basically puts you at, there's minimal risk, but there's possible risk when you,
Absolutely.
yeah. So just, simplifying it that way, that's what I normally do. If you told me you were 40 years old or 38-year-old and you were healthy except for your knee was a problem, I would say, just go ahead and use your bone marrow. Your bone marrow is fantastic. It does. I did bone marrow myself. I've done all of them, and bone marrow is the best for
So
my knee.
have I.
So I've done my own cultured fat cells, my own cultured bone marrow cells, bone marrow, and umbilical cord. And the one that's lasted the longest for my right knee has been the bone marrow aspirate on its own.
Just the plain bone marrow aspirate.
Correct. Yep.
I'm a bone marrow aspirate patient.
I started off working with bone marrow aspirate. I've been through easily 1,000 of them. I've got stored there at least 400 different samples of individuals that we have of bone marrow that we've collected throughout the years, produced mesenchymal stem cells for them, this kind of stuff. So, I work all aspects of any cell type, and they all have different properties, different benefits.
I see. I think in the world right now there's a shift towards, because science evolves, so there is a shift towards these new products that are going to have younger cells, healthier cells, and immune privileged cells. So basically, I think it's not only an option, I think it's the best option for certain conditions.
Yeah, absolutely. I mean, if somebody is older, the older you are, the older your cells are, and that can be problematic. So as you age, the frequency of stem cells in your body is less and less. Simple things that we maybe take for granted, that you have a lot of pain in your body, arthritis, or you're just generally feeling ill, or any little problems, especially when we talk about autoimmune disease, can be problematic because there's most likely an inherent problem with all the cells in your body. Specifically, the immune system has gone array, and we want to use something that's a healthy, young, cell that doesn't have that type of issue anymore, or never had that, or never started off with that, because it's much younger. It's a robust cell type that you can use for different things, and it doesn't require that extraction or the type of procedures that you need to do for it.
Every time you do a nick in the skin, you have a risk of a complication. But not only that, a very common question is why. How do we know that these cells, since these are donor cells, are not going to create a situation where you have a graft versus host disease or any immunological reaction for that matter, because you're using donor?
That's one of the biggest concerns. So that concern is mitigated by simple. There's been, first and foremost, a lot of studies out there, a lot of published studies out there that demonstrate that these products are safe. And the way they're safe is by specific quality control systems that are set in place, where basically you first and foremost have a extensive screening of the donor, meaning mother in this case, and then following that donor screening, the product that you produce has to go through many vigorous steps of quality control to make sure that the product is number one, first and foremost, clean, free of all pathogens, viruses, any form of bacterias, funguses, and yeast, which takes a certain amount of time to actually run these through, and then these products are released. Secondly, when you concern yourself with having graft versus host or something like that, that is done basically because you have a specific protein that is foreign to what's on the cell. And in these cases, these cells are young, they're naive cells, they don't contain that protein that can cause a reaction. So that's why they evade the immune system, and they can actually be incorporated in without any graft versus host disease. And this has been demonstrated, so much so that there's studies out there that, for instance, the cell type that we're talking about, one of them is mesenchymal stem cell. That cell type is used for graft versus host disease, and it's actually approved in Canada for pediatric graft versus host disease. So it suppresses or controls the inflammatory response of the immune system so much that you can use these, so you don't have to put a patient on drugs, sort of say, so they don't, reject an organ or have problems with graft versus host disease.
How does it work, like, to choose the donor, and what's, ballparking, what's the process of obtaining the sample and the lab work and so on?
So the first and foremost, like I said, donors are screened, and they're screened well to make sure by a screening process that it's an acceptable donor. Once the mother has signed an informed consent, understanding that she is donating the tissue or the blood or whatever it may be, at that point then the process commences. There's specific cutoff windows of how long it takes from the tissue or blood to come from point A to point B that has to be acceptable, because basically cells die, as in transit, etc. So there's a amount of testing that's done beforehand to make sure that that's acceptable. Once it's accepted, a unit comes in as sort of say a quarantine unit, because we don't know what else has transpired during transportation or even testing of mother that was done on the spot. That takes about 3 days. General test requirements are hepatitis, HIV, CMV, Epstein-Barr virus, HTLV-1, 2, syphilis, gonorrhea, Chagas even is tested now too. So it's quite a bit of things that are tested. Then the process comes where the tissue is processed. It's processed in a clean room. It's accepted in. It's processed in a clean room, an ISO 7 certified clean room, and it's processed according to strictest standards, where you make sure, depending on what protocols or what's being obtained, you obtaining according to a protocol that's been validated, meaning this protocol has been verified that you've done it several times through, and you get a consistent product, because it's important, because there's variances from one tissue possibly to another tissue. So as long as the processes are maintained exactly the same, then the end point is you should get the right product that you want. Secondly is, once you have obtained that product is quarantined, because then the end product, some of the vials from the end product have to go through more testing, because you did a process to it. So you want to make sure that it's been, for instance, done a USP 71 test, where you test for bacterial and fungal contamination on the product and make sure it's completely clean. You don't want any issues with that, because first and foremost we concern ourselves with safety. And that takes about 3 weeks to get a report. So everything is quarantined until those 3 weeks have passed and you get all clean bill of record on it, and then you're good to go. The testing of such has to be done via a CLIA certified lab, or some form of a certified lab that's actually going to test it the right way. Not done internally. We scientists, we do this easily in-house, and we do a quick and dirty test just to see it, but that's not acceptable. The acceptable criteria has got to be a third party.